Good Tuesday, students. This is Mr. Bauer. I'm getting ready to teach you the lesson 1-5 for Algebra AB for summer school. Okay, please take a look at this lesson. And the lesson starts on page 37 in your textbook. Again, for the way we're doing summer school, the textbook is more of a reference for you to check and make sure that you know what's going on and know how to do stuff, okay? Let me share my screen with you. All right, here is our textbook, lesson 1-5, adding and subtracting real numbers. Okay, so the objective is to find the sums and differences of real numbers. Now, again, real number just means any number that's real, as in not fake, okay? But for our purposes, when we say real number, it's sort of a code word meaning numbers that fit into the categories of numbers that we had talked about earlier, like integer and rational and irrational numbers. Okay, so it's kind of like when we say real numbers, it's not just that we mean numbers that are not fake. We're talking about the categories of numbers. Okay, now specifically in this lesson, the next few lessons, what you need to be concerned with is numbers that are integers, basically negative or positive. Okay, now if you remember the definition of integers are any numbers that can be written on either side of the zero on the number line. Or basically the idea is that they can be positive or negative, okay? So I kind of want to talk about that and exploit that a little bit today. Our focus question for this lesson is what two methods for finding sums and differences of real numbers? What are two methods? You can add or subtract real numbers using a number line model, okay? So, for example, I have positive 3 plus positive 5. When they're both positive, you could just say 3 plus 5. So you start at 3, and then go up 5, and then you are at 8 spaces. So 3 plus 5 equals 8. Now let's take a look at the next one. I have positive 3 plus negative 5 here. So again, 3 is our starting point, but we move 5 units to the left. Why are we moving to the left? Because negative 5 means that we're going down. So on a number line, down is always left, or if the number line is going from top to bottom, literally going down. Okay? So in this case, our answer would be negative 2. Because if we count backwards 5 spaces, starting at 3, we go 2, 1, 0, negative 1, negative 2. So I move 5 spaces back. I'm now at negative 2. So 3 plus negative 5 is negative 2. Okay? You can think of it this way. If positive means up and negative means down, then 3 plus negative 5 means I was walking up a slippery hill. I walked up 3 feet. I lost my footing and slipped down 5 feet. I am now at 2 feet below where I was starting. Okay? So I'm at negative 2 because I'm 2 feet below the starting point of my little hill analogy there. Now, let's go ahead and take a look at the next numbers here. Negative 3 and positive 5. So negative 3 plus 5, we would start at negative 3, and then we would move up 5, and we end up at positive 2 as our answer. Okay? You can see this here in the answer section. Now the next one would be negative 3 plus negative 5. So I start at negative 3. Since I'm adding negative 5, then I go back because I'm adding a negative 5 spots and I'm at negative 8. Now I want you to pay attention to the similarity in the answers. When they were both positive, I got positive 8 as my answer. When they were both negative, I got negative 8 as my answer. When one was positive and one was negative, I got negative 2 when the greater distance from 0 number, negative 5, was negative, and I got positive 2 when the smaller distance from 0, which was negative, and that would be negative 3. So my answers are 8, negative 2, positive 2, -8. Now you might notice a pattern there. The answers are all similar to each other because each of them are going to either be 8 or 2, depending on what you're doing. Now I want to point out something. When the numbers were the same, we added. 3 and 5 are both positive, so you add them and you get +8. -3 and -5 are both negative, so you add them and you get -8. But when the signs were different, we subtracted, like the actual work that you did was subtraction. +3 plus -5, the signs are different, and even though it says to add, we actually subtracted to get the answer. Now, again, we use the number line, but really, who wants to draw a number line every single time you do a problem? That takes a lot of time to do that. So in terms of just doing this without using the number line, I look at 3 and I look at 5, and I subtract the 3 from the 5, and I get 2. And I ask the question, well, which one is a further distance from 0? Well, 5 is farther from 0, even though it's negative. So the one that's farthest from 0 tells you the sign of the answer. The one that's farthest from 0 is -5. Since it is negative, then the answer would be -2. Going down to this question, I have -3 plus +5. My answer is +2. I subtract the 3 from the 5, and I have 2 left over. Since the 5 is farthest from 0 and happens to be a +5, then my answer is positive. I hope that helps you to understand what it is that I'm talking about. Now, continuing on with the lesson, I wanted to step into the next part and giving you guys some definitions that you will need here. So let me go ahead and share screen again with you. Now, adding and subtracting real numbers. I'm just going to try to position this so that it's where I want it. Very good. Okay, let's go over some different vocabulary. Absolute value means the distance to 0. Okay, so when we talk about value, we talk about numbers being higher or lower than other numbers. Like, for example, 5 is higher than 3, so it has a higher value. I would rather have $5 than $3. Okay, now absolute value is the distance to 0. Okay, let's take a number like -5 and a number like +3. Now, +3 could represent $3 that I have. -5 could represent $5 that I owe to somebody else. That's why it's negative, because I don't have it, I borrowed it, and I owe it to someone. Okay? So obviously, +3, meaning $3 that I have, is more money than -5, which is $5 that I don't have. Okay? And since 5 is a negative, then it's definitely lower than a positive. But if I talk in terms of absolute value, then I'm asking the question, not which one is a greater number, meaning which one is furthest above 0. I'm asking the question, which one has the greater distance to 0? Okay, so the greater absolute value would be -5, because -5 is farther away from 0 than +3. Here, I could even show you quickly on a number line. Of course, I did them backwards. I meant to do +3 and -5. Well, anyways, 1, 2, 3, 4, 5. 1, 2, 3. You can clearly see that 5 is further away from 0 than 3. Now, I meant to do it the other way around. I apologize. I meant to do it like this. +3, -5. Okay. Pointing out that that one is further away. Sometimes when you're on camera, it get a little bit mixed up. Apologize for that. Anyways, point being, absolute value simply means which number has a greater distance to 0. Not is it greater by which side of the 0 it's on. Is it below 0 or is it above 0? That's not what matters. What matters is when we compare it to 0, which one is further away. Okay? Now, opposites, I think you know what that means. But for our purposes, we'll use this definition. Opposites are any two numbers with the same distance to 0. I think I'm barely on the page anymore. Opposites are any two numbers with the same distance to 0. So for example, if I say 4 and -4, they would be opposites. Why? Because 4 is 4 above 0, -4 is 4 below 0. Okay? So any two numbers with the same distance to 0, or basically if they have the same absolute value, then they are opposites. Additive inverse is a name that we call any pair of opposites. Any pair of opposites are what's called the additive inverse, and the reason why we do that is because when we add them together, they equal 0. Okay, now let's go back to this one. So if I say 4 plus -4, then it equals 0. On a number line, it would literally be, I go up 4. By adding -4, I go back 4, so I end up starting at 0. Or at my starting spot, which was 0. Okay? So any number plus its opposite is called an additive inverse. And the inverse property is simply the same thing, but just state it more as a verb. If you add opposites, you will get 0. Okay, just wanted to, help you with that. Sorry, got a call coming in. It was a telemarketer. I should have figured. It just had that telemarketer sound to it, didn't it? Moving on. So let's go ahead and continue the rules for addition and subtraction. I want you to memorize this rule. It's very important that you do so. You can write it down in your own notes if you want to, however you can. But if the signs are the same, do what the operation says. If the signs are different, do the opposite operation. Let me say that again. If the signs are the same, do what the operation says. If the signs are different, do the opposite operation. Now, I want to demonstrate. I'm going to do some number problems. I'd like you to write these, if you can, while you are taking notes or just on a notepad, however is more comfortable for you. If I have a positive number plus a positive number, then I will always have a positive answer. That's a property. Remember properties? Anything that we know to always be true. Okay? So a positive number plus another positive number will always be a positive number. A negative number plus a negative number is always going to give you, it's always going to give you a negative answer. I was thinking very positively. That's just a bad pun, by the way. Okay. Now, if I have a negative plus a positive, I'm going to write the letters AV over the top of it, meaning that that positive has a greater absolute value, then my answer will be positive. So if I have -1 plus 2, then -1 plus 2 would equal +1. Okay? Because the number with the greater absolute value is the one that is positive. Okay? Now, if I have a positive plus a negative with a greater absolute value, then my answer will be negative. Now I want to say for the last two problems here, the order doesn't matter. Like for example, this one, I could write it in this order. A positive with a greater absolute value plus a negative is still going to equal a positive. And the same here, I can rewrite this one in the opposite order. A negative with a greater absolute value plus a positive is still going to be negative, okay? So those ones, that I can switch the order and what happens is still going to be true. But I also want to point out something. On the first couple of problems, you'll notice something. If the signs are the same, you notice my signs here are the same, then we do what the operation says, and the operation says to add, okay? If the signs are different, then we do the opposite operation. Here I have a positive and a negative number, so those signs are opposite. So the actual work I do to solve is subtracting, okay? And that's going to be the same when I switch the order of them, okay? I'm hoping that that makes sense for you, okay? If you'd like to pause to catch up, this might be a good time to do it, but otherwise, let's go ahead and continue. Just one of my students. Okay. Now, I want to apply the same rules to subtraction. With subtraction, sometimes it can get a little bit complicated. So let's take, for example, I have -2 minus -1. Okay? I have -2 minus -1. By the way, you can use parentheses with integers because sometimes it's a simple way of separating between the minus sign and the negative sign, or the positive sign and the plus sign. Sometimes that can get really complicated. So by putting parentheses around your entire term, then you're making it easier to see what is an operation, which is that in the center, and what is a number with a negative sign. Now, I'm going to go ahead and make a separate problem, which is +2 minus +1. Now, if they're both positive, you can usually just say it like the kindergarten way, 2 minus 1. So what's 2 minus 1? I see Aaliyah's hand. Okay, good. The answer is 1. Just kidding. I know I didn't see anybody's hand. I know you're not even watching this video at the same time that I'm recording it. But continuing on, I want to show you something. -2 minus -1 is -1. Okay? Now let's go back to the rule here. If the signs are the same, do what the operation says. If the signs are different, do the opposite operation. Now you notice, with the simple problem, 2 minus 1, obviously the signs are the same because it's +2 minus +1. I don't have to write the positive sign if everything's positive. So 2 minus 1 is 1. But where it gets complicated is I have all of these negatives and I see these minus signs and it's frustrating me. Okay? So the idea is I have -2 minus -1. Don't get frustrated. Look at the rule. Are the signs the same? Let's see. I have a negative sign here, and I have a negative sign here. Yes, the signs are the same. So what does the operation say to do? It says to take away. So 2 minus 1 is 1. However, since my problem is all negative, then my answer will remain negative. Okay? In this case, since my numbers are positive, my answer will remain positive. Now, it can get a little more complicated uh, when you start getting numbers that have different signs. Let's try this one, for example. +2 minus -1. Now, I want to remind you that this problem, even though it looks like the other two problems, it's not the same problem because the signs are different, okay? So if it's not the same problem, you can be assured that we're not going to have the same answer. So some of you might be thinking, is it +1, -1? I'm not sure. You're thinking it's going to be 1 something. Well, I'll surprise you, the answer is actually +3, okay? Well, wait, how do you get +3? I'm looking here, I see a bunch of minuses, so that means it's supposed to be like super subtracted. Okay, let's look at the second part of the rule. If the signs are different, do the opposite operation. Let's look at my signs. I have a positive one here. I didn't write it in, so maybe I'll just write it in just to avoid confusion. I have a positive number and a negative number. Okay, so if they're a positive number and a negative number, then that qualifies for being different signs. So since my signs are different, I do the opposite of what it says to do here. It's saying to subtract. Well, what's the opposite of subtracting? It says do the opposite operation. The opposite of subtracting is adding. Yep. Isai, that is good. I'm glad that you raised your hand and told me that. I know I'm just being silly right now. Anyways, so +2 minus -1, if they are different signs, I do the opposite operation, becomes 2 plus 1. So 2 plus 1 is 3. Now you might say, well, I don't understand what I just did. And now some teachers feel like, well, that's okay, just memorize the process and that'll be fine. I think it helps to understand what you're actually doing. So let me just give you a quick analogy. I'll just use money because everyone knows kind of how money works. I have $2. I owe my friend another $1. Okay, I literally borrowed $1. So this negative sign here means owe. That means it's money that I have to give back. Okay, the $1 that I owe my friend is still at home. Subtract also means take away. Okay, so I have $2 taking away the debt or state of owing $1 means that the $1 that I was going to give back, I can now keep, so I now have $3. Okay, let me say that again. $2 removing or taking away the debt or the negativeness of $1 equals $3. Okay, now when we think of negatives, it's weird thinking of them as an actual number that you can add or subtract or take away or put there, okay? Because negatives by their nature take away, okay? But the idea is, since it is just a number, and numbers have to do what operations tell them to do, then I can take away a negative. But if I take away something that's negative, then it automatically becomes more positive. If we were in a traditional classroom and there was a student that had a nasty negative attitude, and I sent that negative student to the office to talk to the principal, then automatically the atmosphere of the room becomes more positive because the negative has left. Now, I'm not saying any of you are like that, so don't take that personal. I don't mean anyone here. So my point is, with subtraction, it works in a similar fashion. Now I'm going to stop the share here for just a minute, And I'm going to pause this video so that you have actually, I'll go ahead and I'll stop this video. I'll do a separate one to show you how to do subtraction. Thank you very much for your time.